Okay, so we're looking here at uh, Introduction to Dimensional Analysis, which is basically just unit cancellation. So we want to start off with a quick review of how to actually do cancellation. Okay, so we're going to start with some basic algebra here. Okay, so here we've got x squared times y over x times y squared. So let's expand that a little bit. X squared really means x times x, and when two things are together like that, it means times that other thing. Then over x times, now in this case, y squared, so x times y times y. So what we're trying to do is get rid of anything that can cancel out. And this is all based on the idea that if something is both the top and the bottom of a fraction, basically looks like this. Okay, so 4 over 4 would simplify with the 4's canceling to basically just be equal to 1. All right, and when we multiply by 1, you know it's the same thing over again. So for all intents and purposes, it just goes away. So here we can see that we've got x's by themselves, both top and bottom, and we've got y's on both top and bottom. So what this would simplify to would be x over y. And this one's a little bit more complicated because it appears in a fraction before. So let's see if we can expand it out and see what happens to this fraction. So b cubed, really b times b times b, over c squared, c times c. Then you multiply by a times c over b times b times b times b. Now, what happens when you multiply fractions? They join in one big fraction, and everything gets multiplied by each other. Okay? So, we've got on this, now it doesn't matter if they're right on top of each other or if there's just somewhere in the top and the bottom. I've got AC, so I can cancel out AC on the bottom. I've got 3b's on the top, so I can cancel out 3b's on the bottom. And what this would lead me to would just be A on the top and then CB on the bottom. And we could write that A over BC as well. It's up to, it doesn't matter. The last one over here we want to talk about is 5z divided by z squared over x times 5y. Okay, so let's, again, talk about what happens when we divide by a fraction. When we divide by a fraction, it's really multiplying by the opposite, or the reciprocal, of that fraction. Okay? And, well, we talked about how to multiply fractions here, but what about when we have a number and a fraction? We want to keep in mind that any number is just over 1. We can turn it into a fraction that way. So let's plug all this stuff in. We get 5 times z, and remember when we see fractions, they all join, times x times 5 times y, all over 1 times z times z. So let's see what cancels out here. Looks like just one z cancels. So we're left with 5 times x times y. That would be 25 xy all over a single z. So not all that much actually cancels. Okay. Well, let's expand that here. We know that whenever we have one number over another, over the same number, it cancels and becomes essentially just 1. The same applies to variables, x squared over x squared. Well, if both of those can cancel, this thing evaluates to 1. The question appears, and this is where it's going to be important for us, what happens when we're dealing with units? Well, then we have to consider what is the relationship between what's on the top and what's on the bottom. In this case, we know that 1 dozen is the same as 12 items, no matter what. So let's think about this. If 1 dozen equals 12 items, 1 dozen is the same as 4 items, or 12 items, I could write 12 items up on top because it's the same. We can just substitute it. And since I can substitute it, we get 12 items over 12 items, it becomes, cancels. It becomes 1. Same way, if I've got 12 items over 1 dozen, I can substitute 1 dozen in for 12 items. And it becomes 1 dozen over 1 dozen, just equals 1. And I can do that no matter which one's on the top or which one's on the bottom. I can substitute either one. Because they equal each other, these things would essentially be equal to 1. Let's see a couple other examples. So Density is something that we've probably been dealing with for a while. Well, let's look at what this actually means. The density of solid iron is 7.874 grams per cubic centimeter. That means that 7.874 grams of iron occupies or takes up 1 cubic centimeter. This grams per cubic centimeter really means, and that's just some number of grams, x grams for every 1 cubic centimeter. Okay? So, when we say that 7.874 grams of iron occupies 1 cubic centimeter, we need to understand that 1 cubic centimeter of iron has a mass, or just masses, 7.874 grams. Okay? Essentially, we can say that these two are equivalent. Because when you have one, you always have the other. So let's take this one step further. If we were to make a set of fractions out of these, and we can flip it the other way, because it doesn't matter which one's on top and which one's on bottom. If they equal each other, we're fine. Okay, we can make those equal each other just fine, because they always go together. 1 cubic centimeter will always have a mass of 7.874 grams. Okay, so it doesn't matter which one we put on the top, they all equal 1. Same idea with speeds. When we say 50 miles per hour, we mean 50 miles for every 1 hour. So again, we can basically say that for whatever car or vehicle is going this speed, 50 miles is essentially equivalent to 1 hour. So if I'm turning this into a speed and into a fraction, I can say 50 miles over 1 hour would be the same as 1 hour over 50 miles, and they both evaluate to 1. Because 50 miles and 1 hour are essentially equivalent in terms of this speed, every hour means you go 50 miles. If you've traveled 50 miles, it means you've gone 1 hour. The top and the bottom here both equivalent. The current 100-meter sprint world record is done at a speed of about 10.42 meters per second. Okay, so again, just to hammer the point home, this goes 10.42 meters for every 1 second. It also means that every 1 second that passes, that runner travels 10.42 meters. Okay, meters, same idea. Let's just put it out to make sure we're all set. And that would both then come down and equal 1. So let's see how we're going to use this. Okay? We can use this idea to help us solve some conversion problems. Okay? All we need to do is come down and identify the relationship between some of these. So the question here is, how many kilograms in 3,250 grams? For that, we need to know a relationship between kilograms and grams. Fortunately, I memorized that 1,000 units is equal to 1 kilo unit. I memorized that 1 unit equals 100 centi-units, and I memorized that 1 unit is equal to 1,000 milli-units, and those are going to need to get memorized. Okay, so I know that 1 kilogram is 1,000 grams, so like I was talking with our density, or our speed, what I can do is take that ratio, or that equality, and turn that into a set of fractions. If that number of grams equals that many cubic centimeters, I can turn them into a set of fractions to use. So let's turn it into like this. 1 kilogram over 1,000 grams, or 1,000 grams over 1 kilogram. And let's see what we're going to do with that. We've got a unit here that we're trying to get rid of. And what we're going to try to do is cancel it and end up with a different unit. I want to get rid of grams. And let's just go ahead and write this out. 3250 grams. And we're going to do something, and I'll give you a hint, it's going to be with multiplication. Alright? And we're going to try to get rid of grams. Right now, we know that grams basically looks like being on top of a 1. Grams is up on top. So I know that any kind of multiplication I'm going to need to do, it's going to end up with grams on the bottom. So I look here, and I go, okay, well, 1 kilogram over 1,000 grams, that ends up with grams on the top and grams on the bottom to cancel out. When I do my multiplication, I have 3250 times 1 all over 1,000 times 1, but you know, basically the same thing. So when I do my math, I get 3,250 kilograms divided by 1,000. So 3.25, because we only have 3 sig figs here. Alright, and that is going to be in kilograms. 3.25 kilograms. Try another example here. Alright, let's say we bought a European cookbook, and all of our volume measurements are in milliliters, but all I have in the house are tablespoons. So I've got two relationships here. 16 tablespoons is a cup, and 1 cup is also 236.6 milliliters. Now, I know 1 cup and 1 cup, alright, so they're basically equivalent, so I could just say, hey, 16 tablespoons equals that many. But that's no fun. So, we're going to try it the longer way, see how it all works. Okay, so if 16 tablespoons equals 1 cup, then I can say that 16 tablespoons over 1 cup, or 1 cup over 16 tablespoons. If 1 cup is equal to 236.6 milliliters, I can also say 236.6 milliliters over 1 cup. So then the question is, what do I do with these things? I've got 600.0 milliliters, and we're just going to assume that that's over 1. And what I want to do is get rid of milliliters. Okay, I eventually want to get to tablespoons. So I look around, what kind of things, what kind of relationships do I have with milliliters? Oh look, here's one. But that's got milliliters on the top. Let's see what happens if I took milliliters times milliliters over cups. And I would end up with milliliters squared over cups, which is not what I want. What I want is to cancel out milliliters. It's on the top right now, so I'm going to choose the one that's on the bottom. And I'm just going to take this entire thing and bring it over here. 1 cup over 236.6 milliliters. Okay. Now keep in mind, if 1 cup equals 236.6 milliliters, those are equivalent, which means basically I'm multiplying by 1. Let's take a look at the next one. I want to go to tablespoons, and I've got cups right now that I need to cancel out. So, oh, hey, look at that. I've got cups on the bottom, which is what I'm looking for. So, 16 tablespoons over 1 cup. Okay, well again, since they equal each other, 16 tablespoons and 1 cup equal each other, I'm essentially just multiplying by 1 here. Okay, I'm not changing the value of my measurement at all. I'm just giving it a different name. Same as right here. Since I'm taking 1 kilogram over 1,000 grams, basically equals 1, all I'm doing is giving this same mass a different name. Okay? 3.25 kilograms equals 3250 grams. Okay, it's just got a different name here. That's all we're doing. So let's do our math. Let's bring out our calculator here. So we've got 600.0 milliliters times 1 cup times 16 tablespoons. We're going to divide by the 1, divide by 236.6, divide by 1. We know that cups cancel out, milliliters cancel out, just leaving us with tablespoons, and so the number we get, 40.5748, we have 4 sig figs to start, so we round it here, 40.57 tablespoons would be our answer. Okay, so I do hope this helped. Always pay attention to your units. If you check out the next video that's coming out, we'll show you how to solve algebra problems having never seen a formula for them before.